using our exponent rules that we learned in the other video. And there's more than one way to approach these, but I usually like to use the fraction bar as a grouping symbol and think about simplifying the top if possible, then the bottom if possible. And so that's what I'm really going to do first. I'm going to go through and I'm going to simplify as much as I can in each separate place and then worry about simplifying the fraction as a whole. So if you remember, when we have two things raised to the same base, as in x squared and x to the negative 3, our rule usually says, we usually say, oh, that means to add the exponents, and we saw why that was true in our previous video. And when we have a power raised to a power, what it means is we are going to multiply the exponents. So up at the top we have x to the second and x to the negative 3. When I add those exponents, I get x to the negative 1. I have a y squared and y, so of course that's going to give me y to the third. And the 2 doesn't have anybody to multiply with, so he just sits out alone out front. And down at the bottom, we had a power raised to a power, so I had to multiply those exponents. Now I'm going to worry about these negative exponents, and when I have negative exponents, since negative exponents means raise the reciprocal to that power, in essence what kind of ends up happening is they're going to switch the place in the fraction. So what's going to happen is I'm going to go ahead and I'm going to, instead of dividing and subtracting all these negative numbers, I usually move them to where they belong to make them positive first and then deal with them, because a lot of times people make mistakes if they're dealing with negative numbers. So I'm going to go through the top and I'm going to write down anybody that has a positive exponent. I'm just going to leave him where he is. And on the bottom, I'm going to go through and I'm going to write down everybody that has a positive exponent. I'm just going to leave him where he is. And then what I'm going to do is I'm going to move the ones that have a negative. If it has a negative, I'm going to switch it to the other place in the fraction. So if it's at the top, I'm going to move it to the bottom. And if it's at the bottom, I'm going to move it to the top. And this way I don't have to deal with any negative numbers. And I think sometimes that makes it a little bit easier for people to not make a mistake, because you're dealing with a lot of little tricky numbers here. And it's not hard math, but it's tedious, and sometimes we lose our place. So now the last thing to do is actually combine these two things with the same base. And again, what do we do in that situation? It means to add the exponents, multiply them with the same base, means adding the exponents. So here I'm going to get y to the 12th times y to the third becomes y to the 15th. And on the bottom, when we add those exponents, we're going to get x to the 17th. And the last thing I need to do is just check that there's nothing else left to reduce. There's nothing that we can combine. There's nothing that we can divide. There's nothing left to do. So this would be the most simplified form of this fraction that we could write, and we would be done. We'll look at one more example while we're looking at simplifying these. So let's take a look at this guy. Now this one is a little bit, looks scarier, but he's really kind of the same thing. And there's a couple of ways we could approach it. We could raise everything to the second power, the negative second power inside here and inside here. But to me, it feels like that, again, I don't really want to deal with the negatives if I don't have to. So the first thing that I like to do when I have this negative on the outside is I like to make it a positive by flipping this fraction, and actually I'm going to multiply the reciprocal to the second power instead of this one to the negative second power. So I'm going to start by just rewriting this basically upside down and changing the exponent to positive on the outside. And now I don't have to deal with that negative. But when I look inside here, I see I also have this whole group that's raised to a negative power. And again, you can deal with it in a couple of ways. You could go ahead and multiply all of them, raise them all to the negative second power. But I think what I'm going to do is I'm going to deal with them the same way I did the other one. I'm going to make the reciprocal happen so that I don't have to deal with a lot of negative exponents, because I find that dealing with negative numbers, oftentimes we make mistakes, and it's sometimes easier to think about them as positive. So if I rewrite them this way, now I have basically all positive exponents. Yes, I see some negatives in there, but there's a lot less than we started. So what I'm going to do is I'm actually going to work on the inside first. And again, you don't have to. You could go ahead and raise everything to the second power. But again, I like to start on the inside of the onion and work my way out just so that I don't make any mistakes or forget anybody. So what I'm going to do, since I'm working on the very inside first, I'm going to work on this little expression on the denominator that's raised to the second power. And I'm going to go ahead and combine anything in there that I can. And I see that I have x to the third and x to the first, and when we multiply those, of course, we get x to the fourth, and I have y squared and y to the negative 1, so when I multiply those, I actually get y to the first, and you don't have to write the first, but I wrote the first there just so that you could see what I was doing. And I can't forget this guy out here, so that's the thing about leaving him to the end. I can't forget about him either. So as we move down, I am actually going to raise everybody to the second power that's in the bottom of this fraction, because I think that will be a good way to deal with it now. And when we raise a power to a power, don't forget that we are multiplying those exponents together. And so I get x to the 8th and a y squared. And again, I'm just going to keep simplifying this denominator until I am satisfied that it's as simple as I can get. And if I keep going, then I'll just do that square thing at the end there, that little square that's hanging out at the top there. And here we have two bases that are the same, and we're raising them to different powers, but what do we do with those exponents if they have the same base? It means we're going to add them. And now there's only one thing left to do, and that is to raise all of this to the second power, and I just have to remember that raising this to the second power means that we're multiplying this together. So it's raising, we have 2 of these, and there's 10 x's here and 10 x's here, so we're really multiplying 20 x's together. You have to remember that you're also multiplying 2 times 2. A lot of people just forget for some reason and don't multiply the numbers. They forget to raise the numbers to that power. So if you think about it in this way, you won't forget. And so this means I'm going to have 1 over 4x to the 20th, and of course I'm going to have 2 y's here that are multiplied and 2 more, so that would be y to the 4th. And there's really nothing else left to simplify. There's no negative exponents. There's no values with the same base. And that's how I know that I'm done. So I can put a box around it and say another job well done.